Hi, I'm Sam. Welcome to my off-grid farm and to off-grid field school. I have spent 8 years learning which quiet building choices keep a small home livable when the weather turns and the power line cannot help. Cold nights taught me to trust measurements before machinery. Today I'm going to teach you why the heater is rarely the first heating decision, how to size a safe heat stack, and which shortcut can leave an expensive cabin cold. Please watch until the end because each layer supports the next, and missing the first layer can make every stove after it work harder. The surprising payoff most people overlook is that the smallest reliable heater often belongs in the best prepared house, not the mildest climate. Start with the shell, then choose the source, then prove the backup. That order turns winter from a fuel emergency into a measured system. The beginner mistake is easy to understand. You arrive at a cold shell, see your breath, and shop for the biggest firebox you can afford. Heat feels like a machine problem. It is really a loss problem first. A heater does not warm a house once. It replaces every unit of heat that escapes through the roof, walls, floor, windows, doors, and moving air, hour after hour. If the shell loses heat faster than the appliance can replace it, a larger fire only hides the defect while fuel use climbs. Think about two identical cabins on the same night. Cabin A has sealed top plates, weather-stripped doors, insulated attic access, and a deliberate ventilation path. Cabin B has an impressive stove beside a loose door and an unsealed ceiling. Cabin B may look warmer on camera because the fire is bigger. At 2 in the morning, it is the one demanding another load of wood. The mistake was made before the stove arrived. The Department of Energy calls the walls, roof, floor, foundation, windows, and doors the building envelope. Gaps where those parts meet let conditioned air escape. Insulation resists heat flow. Air sealing controls unwanted air movement. These are related jobs, not substitutes. Stuffing insulation into a windy cavity does not stop the wind. Sealing a bare wall does not give it enough resistance. You need both, selected for your climate and local code. If the fire dies at midnight, how many safe hours remain? That number tells you more than the stove label. Put thermometers in the main room, the coldest sleeping area, and near vulnerable plumbing. Record outdoor temperature, indoor temperature, wind, fuel added, and the time between burns. One cold evening of measurements beats a month of guessing. If the sleeping room falls quickly while the stove room stays hot, distribution is failing. If every room falls together, the shell is failing. If smoke enters the room or a co-alarm sounds, operation stops immediately. That is a life safety failure, not a comfort complaint. The first avoided mistake, then, is buying capacity before measuring loss. Spend the first weekend finding leaks, not comparing door glass. The heater comes later, after the house tells you what it needs. The system has 4 jobs. The shell slows heat loss. The heater replaces the remaining loss. Thermal mass and room layout spread that heat through time and space. A separate backup covers absence, illness, fuel interruption, or equipment failure. None of those jobs can impersonate another. The governing principle is simple. Size from the coldest credible night, then reduce the load before increasing the appliance. Credible matters. You are not designing for an imaginary record that never occurs, and you are not designing from last week's mild afternoon. Use local design temperature guidance, a qualified heat loss calculation, and the actual materials in your shell. Guessing by square footage alone ignores ceiling height, glass area, air leakage, wind exposure, and insulation quality. Start with a paper map. Mark the heated zone, sleeping rooms, plumbing, exterior doors, chimney route, combustion air requirements, and every place a pipe can freeze. Then mark the rooms you do not need to keep at living room temperature. Zoning is not neglect, it is control. A compact warm core with protected plumbing can be safer than trying to hold an entire unfinished building at one temperature. The shell inspection runs top-down. Check roof and attic penetrations, attic access, wall-to-ceiling joints, window and door seals, rim joists, floor edges, service penetrations, then foundation and crawl space. Do not seal intentional vents, combustion air paths, or moisture control assemblies. That is why local code and a competent building professional matter. A tight home without planned ventilation can trap moisture and pollutants. Tight means controlled, not suffocated. The cheapest heat source is the heat you stop losing. DOE material explains that higher R-value means greater resistance to heat flow, but required assemblies change by climate zone and construction. Do not copy one internet wall stack into every location. Ask 3 questions. What is the required assembly here? Where is the air barrier? And where can moisture dry? Those questions prevent the classic repair where condensation grows inside a wall that looked efficient on paper. Only after that map is honest do you choose a primary heater. The order is not exciting, but it is repeatable. Measure, reduce, size, install, test, then write the backup plan. For many rural off-grid homes, a certified wood stove remains attractive because fuel can be stored on site and useful heat does not depend on a large electrical load. But wood independence is not automatic. It needs dry fuel, daily labor, safe storage, a compliant chimney, ash handling, inspection, and someone physically present to operate it. The EPA makes an important distinction between combustion efficiency and overall efficiency. Combustion efficiency describes how completely the fuel burns. Overall efficiency asks how much useful heat reaches the room. Advertising may feature the higher number. Compare certified overall performance for the exact model and installation, not a slogan. EPA guidance also says a certified appliance can use up to 1/3 less wood than an older inefficient heater for the same heat. Fuel quality decides whether that advantage survives. Properly dried firewood should read 20% moisture or less according to EPA guidance. Test a freshly split face with a moisture meter. Wet wood spends energy boiling water, produces more smoke, and encourages creosote. Stack wood off the ground, protect the top, leave the sides open to air, and keep the active supply away from the stove's clearance zone. Never burn treated wood, rubbish, or anything the appliance manual forbids. The fireplace is the visual trap. EPA notes that a wood-burning fireplace is generally inefficient and can pull warm room air up the chimney, cooling other rooms. A beautiful open hearth can therefore make the rest of the house colder. If an existing fireplace is part of the building, treat it as a separate appliance problem. A listed insert may change performance, but the chimney, clearances, liner, hearth protection, and installation still require qualified review. A clean flame does not prove safe room, air, or safe draft. Choose the appliance after a heat loss calculation. Oversizing encourages short, dirty burns and uncomfortable temperature swings. Undersizing creates non-stop firing with no reserve. Bring the floor plan, envelope details, ceiling height, window area, and climate information to a qualified installer. Place the stove where heat can reach the protected core without forcing bedrooms to overheat. Follow the listed clearances and floor protection exactly. Internet rules of thumb: never override the manual or local authority. Finally, commission the system. Test draft, observe startup and shutdown, confirm smoke does not spill, check alarms, and record indoor temperatures during a real cold spell. The goal is not the biggest fire. It is a predictable house. A primary stove solves only one failure path. What happens when nobody can feed it? The chimney needs repair, wood is wet, or illness keeps you in bed. The second layer should fail differently. A sealed combustion propane or diesel heater may provide controlled backup where it is lawful and correctly installed. Sealed combustion means the appliance takes combustion air from outside and sends exhaust outside through its listed system. A portable unvented heater is not equivalent. Never improvise a sleeping room solution around an appliance not approved for that use. The backup needs its own energy ledger. Record fuel storage, safe storage location, expected runtime, electrical draw for fans or controls, ignition method, service interval, and minimum battery reserve. A pellet stove, for example, may burn a convenient solid fuel, but commonly depends on electricity for its auger and fan. If the battery fails, the heat plan can fail with it. A fuel heater with a blower creates the same question. Your power budget must include heating auxiliaries during the worst solar week, not the annual average. Distribution is the hidden job. Open plans move radiant and convective heat differently from divided cabins. High ceilings collect warm air, closed bedrooms and remote plumbing stay cold. Use quiet, low-power air movement only where the appliance and building design allow it. A small transfer fan or ceiling fan on a gentle setting may equalize rooms with far less power than another heater. Measure before adding equipment. Place sensors in the cold zones, not beside the fire. One warm room can still hide a pipe approaching freezing. Thermal mass changes timing, not total energy. Masonry near a suitable heat source can absorb heat and release it later, reducing swings. It cannot rescue an unsafe DIY flue or create energy. Rocket mass heaters and homemade systems deserve special caution. Legality, insurance acceptance, draft behavior, surface temperatures, and carbon monoxide risk vary. If a system is not listed or accepted locally, do not present cleverness as approval. Your final stack might be a tight shell, a properly sized certified wood stove, passive daytime gain, a small circulation plan, and a listed sealed combustion backup. The exact equipment changes. The 4 jobs do not. Combustion changes this from a comfort lesson into a life safety lesson. Carbon monoxide cannot be seen or smelled. Install battery-operated or battery backup code detectors as current local guidance and manufacturer instructions require, including near sleeping areas. Test them. Replace them at the end of their listed service life. A detector is not permission to run unsafe equipment. It is the last warning layer after correct installation, venting, maintenance, and operation. The CDC instruction for portable generators is clear. Operate them outside, at least 20 feet from the house, doors, windows, and vents. A garage with the door open is not outside. A porch beside an intake is not outside. Exhaust can enter through openings and collect indoors. Generator power may support a backup heater, but the generator never becomes an indoor heat source. Fire safety gets the same discipline. NFPA guidance calls for a 3-foot zone around heating equipment free of children and anything that can burn. Treat that as a broad household rule, then obey any greater listed clearance in the appliance manual. Keep drying gloves, stacked wood, furniture, curtains, and pet bedding out of that zone. Have heating equipment and chimneys inspected and maintained by qualified people on the schedule required for the system and your use. A 1-page card must work for another person at 2 in the morning. Watch for failure signs: smoke smell indoors, soot where it should not appear, difficult starts, weak draft, unusual condensation, damaged seals, chimney discoloration, alarms, headaches, dizziness, nausea, or confusion. If a co-alarm sounds or people have symptoms, move to fresh air and contact emergency services. Do not silence the alarm and restart the heater to see if it happens again. Write that card. Include normal startup, safe shutdown, fuel limits, clearances, alarm response, emergency contacts, backup heater steps, generator placement, and the point at which the house must be evacuated. Add photos of controls if needed. Store a flashlight, spare detector batteries if the model uses them, an extinguisher of the correct type, and the appliance manuals where they can be reached without crossing the hazard. Then run a drill. Let a second adult start and shut down each approved system while you watch. Simulate a blocked primary heater. Simulate a low battery. Confirm the coldest room remains protected. The drill exposes instructions that exist only in the owner's head. Take a small 2-bedroom cabin in a cold inland climate. The owner plans a large stove because the previous occupant complained about winter. Before buying, they inspect the envelope. The attic hatch leaks, 2 plumbing penetrations are open, the door sweep is missing, and the sleeping room window does not latch. Those defects are repaired with assemblies suited to local code. Planned ventilation and combustion air remain intact. The owner then commissions a room-by-room heat loss calculation instead of sizing from floor area alone. The result is a smaller listed stove than expected. That saves more than purchase price. The chimney route is simpler, the room is less likely to overheat, and normal burns operate inside the appliance's intended range. The owner adds a moisture meter, covered wood storage, and smoke detection, a 3-foot clear zone, and a thermometer in the cold bedroom. A sealed combustion backup is selected for lawful installation, and its blower drawer is entered in the winter battery budget. A heater budget without fuel, chimney, alarm, and backup is incomplete. Now change the first variable, wind. On a calm night, temperatures hold. During strong wind, the cold bedroom drops faster. That points back to leakage or distribution, not automatically to stove capacity. Smoke testing and a qualified inspection find the remaining envelope path. Fixing it improves every future hour of operation. Change the second variable, absence. The household leaves for 10 hours. A hand-fed stove cannot provide unattended heat unless its approved operating cycle safely covers that period. The backup set point protects plumbing and the sleeping zone. Fuel and battery runtime are measured, not assumed. If the backup cannot cover the absence, the plan changes before winter travel. Use 4 cost columns. First is load reduction, assessment, air sealing, insulation, repair, doors, windows, and moisture control. Second is primary heat, appliance, chimney, hearth, permits, professional work, tools, and fuel storage. Third is safety and maintenance, alarms, inspection, sweeping, replacement parts, and train service. Fourth is resilience, backup heater, safe fuel reserve, battery capacity, sensors, and freeze protection. The worked lesson is the outcome promised by the title. The wrong choice is treating the heater as the system. The right choice is a measured stack where the shell, appliance, distribution, safety, and backup are sized together. Here is the field checklist. First, define the heated core and protect every pipe that matters. Second, inspect and measure the envelope without blocking planned ventilation. Third, obtain a real heat loss calculation using local climate and actual construction. Fourth, choose a listed primary appliance that fits the load, fuel supply, labor, and legal context. Fifth, design the chimney, hearth, clearances, combustion, air, and maintenance access with qualified local help. Sixth, add smoke and carbon monoxide detection, the 3-foot clear zone, and written emergency steps. Seventh, choose a backup that fails differently and include its fuel and electricity in the winter ledger. Eighth, run a cold weather stress test and repair the weakest result. The final test is whether every cold zone stays inside its limit. If you burn wood, use dry seasoned fuel and confirm moisture on a newly split face. If you depend on electricity for a blower, auger, pump, or controls, measure the draw and protect the battery reserve. If you use daylight gain, measure the room after sunset as well as at noon. If a remote room or pipe stays cold, solve distribution or zoning instead of turning the stove room into a sauna. The direct answer is this. The heating choice that leaves off-grid homes frozen is choosing an appliance before choosing the heat loss strategy. It feels productive because a stove is visible. The shell, sensors, clearances, fuel practice, and backup are quieter. Those quiet parts decide whether the fire remains a comfort or becomes a daily emergency. The smallest first move is a thermometer set, a written room map, and an envelope inspection. The next is qualified local advice on load, code, chimney, and insurance. Do those before buying used equipment. Keep official DOE, EPA, CDC, and NFPA guidance in the source file, then check the appliance manual and your local authority before construction. No video can approve a heating installation. Climate, codes, insurance, fuel, and buildings vary. Stop using any system that spills smoke, triggers an alarm, shows damage, or causes symptoms. Move people to safety first. Diagnose second. The payoff is not a bigger flame. It is waking on the coldest credible morning and finding the sleeping room, plumbing, battery, and fuel reserve all inside their planned limits. That is what safe below zero should mean, not bravery, not a dramatic stove, but a house that was measured before winter asked the question. Build the shell, size the source, protect the air, prove the backup, then let the fire be the simple part.